you have your server. This is called the safe, S-A-F-E, something like secure authorization for Encase. This is a server that sits and runs all the time. Hopefully it's physically secure. This is basically the trusted introducer and the gatekeeper that decides whether or not a person is allowed to grab a hard drive, right? So you have a server with a bunch of keys on it. It has an admin interface that allows you to configure who can do what, and it knows who all the users are, and it sits out there to authorize people and to introduce them to the targets. You got the keymaster, who we're not going to talk about, but that's basically like a super user. And then what they call the target machine is also called a servlet, which is an overloaded term for all you people that do Java stuff. But Encase calls, to make this stuff happen, you have to put a little piece of software on the target machine, and that piece of software is called the Encase Enterprise Servlet. So if I use the term servlet and target machine interchangeably, I apologize. So basically what happens is this is during the initialization of the crypto system. You install the safe. The safe generates a bunch of keys. It sends them to the vendor. There's a human in the loop process by which you say, yes, I'm the person that bought this product. I'm not sure exactly how it works because we haven't done an install, but I'm guessing that it's fine. There's a human in the loop process where guidance then signs the safe keys from the server. Now, this little arrow is a kind of a mystery to us. Somehow, the individual target machines are told of what the public key is of the safe. This may be through some network process. It looks like, from what we've observed, they actually roll a setup.exe. They roll a binary for the servlet that has the public key burned into it, which would be a totally fine process. So we won't comment too much about this because we're not sure exactly how it works. That is how it works. Okay, because I've seen also in some other situation, it's not been made, that's a version issue. So you roll a binary after you do your install. Now I'm able to get a setup.exe from the safe, and that setup.exe I push out to all of my users. Right? A lot of enterprises that use Encase Enterprise have the servlet running at all times on all of their desktops because they don't want to have to make any changes to those desktops that they have to do an investigation. Right? They just want to go and do it and pull the hard drive down without authenticating it and pushing out the servlet. So imagine in our scenario, every single computer inside this 10,000-person enterprise is running the Encase servlet at all times, bound to port 445. It's just a TCP port. So this is the initialization and the install. When it's time for me as the examiner to do an acquisition of a hard drive, I have to authenticate myself to the server. This works fine. This process works fine. The server authenticates me. It looks me up in a list, some kind of authorization database. It says, okay, Alex is asking for access to grab Bob's computer. He's in the list and he's allowed to. Okay, that's great. So it does that. It generates some session keys and it sends it back to the client. I'm sorry, I kind of missed a point. The client has, every single examiner has a licensed certificate, public-private key pair, that has to be bootstrapped at the safe. That's a totally secure process. It's fine. So basically, I'm introduced as the client to the server. We create a trust relationship, and we create some symmetric keys that we share with each other. Works great. This is where this whole system falls down. Now, the process of putting servlets onto individual computers is a couple ways. You can put it in your standard build. You could use like an Active Directory group policy to have them automatically install. You can use a little GUI inside of Encase, which does a DCE RPC call to push down setup.exe and then run it on the targeted machine. You need to make sure you're using NTLM v2 when you do this. That's a possible issue if you don't have a secure Windows network. Not a big deal. That's not Guidance's fault. That Windows authentication protocols aren't that good. But no matter how you do this, every single machine in that 10,000-person enterprise is given the same setup.exe file, right? It's binary identical for every single machine, and that's an important point to remember, right? Because what does that mean if it's identical for every machine? It has nothing special about it that's known before it's put onto the individual machines. Right. So now we've got 10,000 machines. They're all running the servlet service. And the safe has received a request that I want to grab Bob's computer. So it generates a random number. It signs that random number with its private key. And then it sends it to the target, right? The target verifies that random number, generates its own, and then sends the two random numbers back, encrypted with the safe's public key. What's the problem here? not initialization vectors. Let's assume the implementation is correct. This is a trust introduction. I'm trying to establish trust with this target machine. It's only half trust, right? All we have verified is that the safe has a public key that is known by the servlet. Nothing that is done here in this package that comes back to the server, nothing in it is different depending on which computer you go to. Sure, there's a random number, but the random number is just random, and there's nothing to verify against that. There's no signature, there's no shared secret, there's no name, there's nothing in this bootstrapping that identifies the target machine. And then we do a couple more things, and basically what this does is we generate a session key that is given, the safe generates a session key, it gives it to the target, it gives the same session key to the client, and then these guys can talk to each other because they're now sharing the session key, right? The safe is a trusted introducer. It's a server that both sides trust, and it introduces both sides. But when it does that introduction, it does no verification of who the target machine is. So what does this mean? Redirect it to another host, yes. There is no authentication of what machine you're talking to in Encase Enterprise when you pull down a hard drive or grab its memory image. Encase is relying on the idea that if I take a DNS name, bobscomputer.corp.com, and I resolve it to an IP address, and then I send a packet to that IP address, it's really going to get to Bob's machine.
Or you specify the IP address.
Or you specify the IP address. Right, which a lot of people do. I'm sorry?
You look at the data on the machine to see the person.
Okay, so we'll get to that. So basically, the only thing that actually gets verified is that the client machine sends an IP address to the target of what it's expecting. So the target servlet looks up locally in the registry what's my IP address, and it checks that that's the same. Okay, great. The practical effect of this is that standard network attack techniques allow any person on a switched Ethernet network to redirect a request to Encase Enterprise to a virtual machine under their control or a physical machine under their control. And we can talk through the scenarios in detail, and you cannot believe me if you want. But basically what it means is if I'm Malice, and I'm on the same Ethernet network as Bob, and Alice comes to get Bob's hard drive, I can grab that packet, send it to my virtual machine, and now Alice gets my hard drive.
I'm sorry, it doesn't work.
What doesn't work? Right, you can't do a direct network port redirect. You have to do something like an ARP spoof because the machine you hand it to has to believe itself that it has the same IP address as Bob's. Yes. We've tested taking different machines, giving them the same IP address, and it doesn't figure it out. Right, because all it's going after is the IP address.
So all right, this is all great information.
Yeah.
I'm looking around this room and I'm seeing there's about 70% of the people in here who follow directions to do this.
Right.
And get it done. I'm working for a corporation that has 300,000 employees. And I'm saying that maybe 100% of the people in here have the capabilities. That narrows me down to less than 1%.
We'll make tools to make it easier.
Okay, well, I'm not saying that people are... Okay, so the tools so right now, there are tools that allow you to do DNS spoofing in a corporate DNS environment. There are tools, if you use bind in a DHCP server, you can do all this just through race conditions because the magic ferry protocols, right? The same magic ferry that allows your computer to work when you plug it into the Ethernet port, and the magic ferry comes and sprinkles the magic fairy dust, and there's all these magic protocols that make everything work, right? You get an IP address, you get a DNS name, you get a DNS resolver, all of a sudden you're able to figure out the MAC address of your gateway. Those are all insecure protocols, and that's been known for a real good long time. DSNF, Canonable, ARP spoof, all the DNS attack tools. So the basic problem is, and you're right, if Alice looks at that virtual machine, she might be able to figure out that it's not Bob's hard drive, right? Because it doesn't have Bob's files on it, or it doesn't have the proper stuff on it, or it doesn't look like it's been used correctly. The problem here is using Encase Enterprise is not the equivalent to a police officer going to the floor of a building, walking over to the computer and grabbing the hard drive. Encase Enterprise is the equivalent of a police officer going to the floor of the building, looking out at the cube farm, and saying, who here has Bob's hard drive? And the first person that comes to him with a hard drive, he takes it and he puts a stick-it note that says, this is Bob's hard drive. Now, in that situation, the person could still look at the hard drive and try to figure out whether or not it's Bob's, but there's no authentication via the way he got it that allows him to do that, right? And I'm not going to speak to the legal implications. Chris will do that in just a second. But I don't think that's what people's assumption is when they type in the name of the machine, right? Okay, so there's basic flaws here. We also started on the network thing. Obviously, also, the NK servlet isn't really hardened against reverse engineering at all. It's actually linked against debug symbols, the production one. So if you're examining somebody who's an advanced user, it would not be that difficult to take a normal Windows rootkit and modify it to understand what the NK servlet is, and make sure to feed it a hard drive that, you know, maybe that the rootkit now hides a couple processes and hides the second hard drive, right? NCase only sees physical drive 0, doesn't see physical drive 1.
Hey,
so that's a standard problem. Yeah. Right. So suggestions, there are a couple ways. There's no way to solve the problem of I go to somebody's machine and ask it, give me your truthful hard drive. That's not possible without a trusted computing base. You can make it much more difficult to quote-unquote frame somebody and to mess with acquisitions over the network. You could use Active Directory Kerberos trust relationships that already exist to bootstrap that protocol. And you could also do like a registration thing where the servlet generates a key pair, it registers, keeping that mapping between I'm Bob's computer and that key pair might be hard, but at least that creates an audit trail that you can go back and check if you think that anything funny has happened. Right now, our suggestions are, if it was us using NCase Enterprise, I think it's fine for using for incident response on a production server. It's fine for initial investigations or phishing expeditions or whatever you want to call it. An initial look at your marketing department, you're probably fine. If you think somebody's doing something illegal and you want to prosecute them, I would strongly suggest getting the physical hard drive later so that you can prove that you grabbed the right image. I would do all of your court testimony on that physical image. I would be very careful investigating your system administrators using NCase Enterprise because it is pretty easy to trick if you're the local admin. And save that, either the image or the physical disk itself that you got from the physical process, save that forever. Do not use NCase Enterprise and then put the desktop back into circulation, right? And I know that sounds obvious, but we've heard that has happened, right? That people just assume that the NCase Enterprise image is good enough, so we don't actually have to grab the desktop. Anyway, so our conclusions from all this study, the forensic software vendors are not paranoid enough. They do not use coding practices that are commensurate with the danger that they face from parsing such data that's under a control of bad guys. They do not take advantage of all the protections for native code. In our paper, we outlined the fact that the use of the Aladdin token for NCase Enterprise makes it impossible for NCase Forensic, makes it impossible for NCase to use the anti-buffer overflow protections provided by Windows. It turns off DEP and it turns off stack protection because they're doing a packed binary for anti-reverse engineering. So that token makes them more secure against copy protection and makes you less secure against buffer overflows. Forensic software customers do not use security as an acceptance criteria when evaluating software, right? This includes the government, which does all these tests, and if you look at all the government tests, not one of them is about security. They're all about software following through and doing exactly what they expect when they give it a controlled data set. So they test, can NCase copy this hard drive? They don't test, can NCase copy these 100,000 randomly fuzzed hard drives? Because that's a hard thing to write down as a rule, right? But that kind of QA doesn't happen. The software and methods for testing forensic software need to be more public and complete. The fact that nobody's talked about the NCase Enterprise stuff since it came out like 3 or 4 years ago is because it's not well documented and there was no cryptographic review by open cryptography.